cooling water comes in here, goes out of here, and this is condensed, and it's two phases, and this is a very simple, oversimplistic representation of distillation. Now let's see what this is saying. Somebody had written some comments on it. It's not my writing, so I'm going to have to figure it out like you. The same thing, this one does not have a cooling here. It says high vapor pressure, low temperature. There is heat and bubbles. I think this is more of an explanation of the same thing. I can't explain anymore. Pardon?
There's no heat on the second.
There's no, here, there's heat here, it says. But there's no cooling on the first one. I don't know what it means anything. And maybe natural cooling. It's similar to the other one, except that this has no cooling here. Of course, there'll be condensation because of natural cooling, but this arrow says high vapor pressure, low temperature. So this one vaporizes easily, and the temperature is outside low, I suppose. So it's effectively the same thing is happening as before, a different representation. This one is a single plate bubble cap column. Okay, this is of course, you don't have a single plate bubble cap, but this is an oversimplification. This is the bubble cap here, and heat. Okay, let's see. This is boiling liquid. It goes in here, and there's intimate contact between the liquid and vapor, and the liquid condenses. The vapor keeps on going, and it's taken overhead. It's cooled, and it's condensed, and part of the condensate is returned as reflux to help in the separation. There's a liquid level. It's a single bubble cap. It's just, it says good something. I'm not sure what it says. Dispersion, okay. Descending condensate. So the condensate descends, the vapor rises, and the bubble cap allows them to be intimately contacted. The next one is a typical light ends tower. The feed is fed in here. Almost always when you have this type of tower, you try to exchange the bottom material against the feed to regain the heat. So the feed comes in, it's heated up against the leaving product. And there's a bunch of trays here. The vapor goes up, and each tray has either it's a sieve tray or a bunch of bubble caps. We'll talk about those details a bit later. So you end up a similar result as in the earlier slides. The overhead is condensed, and there is a receiver, and off gas is taken. It's a dash point. That means if this is two-phase, if there's light material, and when I say light material, very light material like gases, methane, ethane, propane, and heavier material like C4, C5 material, then you have a two-phase, and you end up taking an off gas. Otherwise, you don't have this stream if it's total condensing. And then the liquid is refluxed back to the column with the net product taken out, because we have to have a material balance. The feed keeps on coming in, so something has to leave the column. And similarly, in the bottom, you have a reboiler, so you put the heat this way.